So atoms and, I'm sorry, elements and compounds are both pure substances. So we've got pure substance, elements, and compounds. The elements we can divide into two groups. There's two possibilities. They can be atomic, meaning their smallest particles are atoms, or there are some elements that are molecular. This is an element, oxygen, because it only has oxygen atoms in it. But it's a molecular element because each molecule has two oxygen atoms. They're not oxygen atoms by themselves, like neon. Most elements are atomic. With compounds, there are molecular compounds with covalent bonds. There are ionic compounds with ionic bonds. So most elements are atomic. They have single atoms as their basic unit, but there are also molecular elements. They've got two or more atoms of the same element bonded together. So there are 7 diatomic elements. These are diatomic because they have 2 atoms in their molecule. So each of these, H2, N2, the subscript 2 tells me it's a diatomic element. There are others, polyatomic, that have more than 2, P4 and S8 are examples. There are others. You shouldn't be shocked if you see a formula like that, but I don't expect you to know that sulfur can come in S8. You do need to know these 7 diatomic guys. So how can you remember those guys? Well, I have a couple of different methods. One is a silly sentence, or a mnemonic. Horses need oats for clear brown, eyes. Everything's going along so nicely. This is Br for bromine, Cl for chlorine, F for fluorine, O for oxygen. Let's get rid of that. No, I'll do it this way. If you start this 7 and you're not sure how far down it goes, it actually doesn't matter because astenine and, I'm not even sure the name of that one, TS. We're not going to run into those in organic in this class. TS. I don't know.
It's not even named on that one.
Yeah, it's not even named on this one. It's one of those new elements. It's man-made, so definitely won't be running into that. Molecular compounds. We talked about covalent bonds, right? Molecular compounds have covalent bonds, and they're going to be nonmetals. So the basic unit of these compounds are individual molecules. Examples are water, dry ice, and propane. Here are the little space-filling models of propane. So these guys are different than an ionic compound where they're just alternating atoms all stuck together. You have discrete molecules. You could say that, this is like a family unit or something, and they're going to travel around and they're going to see stuff, but they're going to stay together. Ionic compounds are going to have ions in them. So the cation, almost always a metal. There's one exception we'll deal with in Chem 1A, and I'll mention that. And then you're going to have anions, and those are going to be one or more nonmetals. And so the basic unit here is called a formula unit, which is really the empirical formula for the compound. Because if we look at one of these salt crystals, if you think of that as a molecule, because it's one unit, everything's connected there, how many sodium atoms and how many chlorine atoms are there? Well, it would be extremely difficult to find out the exact number, and it's not even helpful, right? So with ionic compounds, we're always going to be looking at the lowest ratio of the ions. So sodium chloride, we have sodium ions and chloride ions. There's one sodium ion for every chloride ion. So we're going to refer to that as NaCl. There's not a molecule that's one sodium and one chlorine. Sodium chloride is an ionic compound, and it makes these big structures. There are polyatomic ions. So a polyatomic ion has more than a single atom in it, and those atoms are covalently bonded together. So they're kind of like a molecule, except that they aren't neutral, they have a charge. And you might be wondering, well, why do some do that and why others don't? And those are great questions, but I can't really answer them right now because we haven't learned enough. So just be okay with this is what they are. So polyatomic ions. When we look at ionic compounds, in Chem 1A, there will always be two kinds of ions. There'll be one kind of cation and one kind of anion. So if we look at NaNO3, students sometimes want to tell me there's a sodium ion and a nitrogen ion and 3 oxygen ions. And I understand why your brain wants to do that, but please don't. 2 ions, one positive, one negative. The first element in an ionic compound is almost always a metal. That's the cation. And then if you cover that up, what's left? Everything that's left together is the anion. Okay? Everything is left. So this guy has a sodium ion and a nitrate ion, NO3 minus. There's calcium carbonate. The calcium is one ion, and the CO3 is the other. We're not going to have the Ca and the C be together. It's always going to be the metal and everything else. Okay? KClO, again, the metal and then everything else. And we're going to talk more about those polyatomic ions soon. We need to be able to classify substances as atomic elements, molecular compounds, or ionic compounds. So let's practice that. Fluorine. Element or compound? Element. So I'm going to put E for element. How would we know that? Well, fluorine is one of the elements you're supposed to memorize the symbol for. If you can find it on the periodic table, it's an element. If it has a single name, like fluorine, as opposed to carbon fluoride with 2 words, it's most likely an element. Is this atomic or molecular? Molecular. Horses need oats for clean brown eyes. So F is at the corner of that 7. So this is a molecular element. It contains little molecules of 2 fluorine atoms. Okay, this guy, element or compound? Compound. Each atom has a symbol that starts with a capital letter. So here we see we have 2 capital letters. We automatically know there's 2 elements. So it can't be an element, it has to be a compound. Is it molecular or ionic? It is molecular. How do we tell that? The first element is not a metal. How do I expect you to know that nitrogen is not a metal? Well, hopefully you know that there's a lot of nitrogen in the air, but maybe you don't know that. We're going to use the periodic table. So you find N on the periodic table, and you see which side of the stair-step line is it on. It's on the non-metal side. Hopefully everybody knows that oxygen's not a metal, right? So oxygen's on the non-metal side, and iron, we all recognize that as a metal. That's on the other side. Okay. So 2 nonmetals, it's going to be molecular. Silver. That's going to be an element. It's going to be an atomic element. Single word, silver is on the periodic table, and it's not one of the 7. I would not trick you and say phosphorus and expect you to tell me it's a molecular element. The only ones you're responsible for are the diatomic ones. How about this one, K2O? That's an ionic compound. Ick. Potassium is a metal. How do you know that? Well, you find it on the periodic table. It's way over on the side with the metals. First element is a metal, boom, ionic compound. Doesn't matter what's after it. How about Fe2O3? Also an ionic compound. Okay, any questions about that? Yeah.
So if it's just an element on its own, then it's either atomic or molecular.
Mm-hmm.
But if it's a compound, it can be either molecular or iconic.
Ionic. Yeah. Some of the ionic compounds are a bit iconic. Yeah, so those are the choices we have right now.